Module 3. The basic structure of skin. The integumentary organ system is composed of the skin, glands, hair, and nails. We'll first begin by learning about the skin. There are two layers to your skin, the epidermis and the dermis. The epidermis is the outer portion of the skin formed by the epithelial tissue that is attached to the dermis. The dermis is dense, irregular connective tissue that forms the deep layer of the skin. I already discussed the tissues of the skin in the last module, but you may remember that the epidermis is made of stratified squamous epithelial tissue. Remember that stratified means it is layered like strata, and squamous means it is squashed or flattened. The dermis is composed of dense, irregular connective tissue. Remember that it is dense because it has a greater amount of collagen fibers, and they are arranged in an irregular fashion. When you get a blister, you are experiencing a separation between the epidermis and the dermis. The area between them is filled with fluid. There is sometimes a third layer below the dermis called the hypodermis. The prefix hypo means below or under, so it is under the skin. The hypodermis is loose connective tissue underneath the dermis that connects the dermis to muscle or bone. It is not a part of your skin. The dermis is actually made up of two layers, but those layers are hard to distinguish from one another because they gradually change. The upper part is called the papillary layer. It is bumpy on its upper surface. We call those bumps dermal papillae because papilla means bump. They are there to increase the surface area of the dermis so that more blood vessels can be there for the epidermis. Remember that the epithelial tissue is avascular, so it needs to be close to blood vessels to receive nutrients and remove wastes. Open up your hand and take a look at the tips of your fingers. Look closely at your fingerprints. Those are technically called epidermal ridges. Now, epidermal ridges are located all over your skin, but the skin of your fingertips is unique. You see, your skin develops its epidermal ridges based on the environment around you. Even identical twins have slightly different environments while they are developing in the womb, so they have different fingerprints. Well, besides identification, fingerprints serve another important purpose. Those deep ridges create greater friction so you can better grasp objects. Your grip, even when your hands are wet, is much tighter because of the extra friction created by your fingerprints. Hands are designed to grasp and hold onto things, so not only do you have deep ridges on the tips of your fingers, you have deep ridges all over the palm of your hand. These ridges are more pronounced on the soles of your feet, too. Now, though your feet are not as useful for grasping, unless you're very flexible, the deep epidermal ridges there provide greater friction against the surface of the ground as you walk. Epidermal ridges are a result of your dermis. The lines of dermal papillae, or the rows and rows of tiny bumps in the dermis, create the ridges you see. The epidermis lies on top of the dermis like a blanket over a bumpy bed. Thus, the folds of the dermis are visible on the epidermis. Below the papillary layer of the dermis lies the reticular layer. Reti means net. You will find this root word in several biological terms. Remember the endoplasmic reticulum? It's a network of tubes in cells. In the same way, the dermis's reticular layer is a network too, but it consists of collagen fibers. Now, you already learned that the dermis is composed of dense, irregular connective tissue. The collagen fibers are arranged in an irregular manner, and there are a lot of them. This fiber network, then, gives the dermis strength in all directions so that it will not easily tear when it's stretched. Rhinos are known for their wrinkles in their skin. Even young rhinos have wrinkles on their skin, so we know there's something more to it than age. It's a result of the collagen fibers and their orientation in their skin. Humans have the same situation, although thankfully our skin doesn't wrinkle as much as theirs does. Dense irregular connective tissue is made up of densely packed collagen fibers that are not lined up parallel to one another, but there is some arrangement to them, and so it causes predictable lines of folds in our skin called lines of cleavage. You can see those lines of cleavage patterns in a diagram in your textbook in the human skin. For example, when I raise my eyebrows, you'll see lines of folds of my skin going this way. It's because I like you guys enough to show you my wrinkles. If I were to get a cut perpendicular to those lines of cleavage, the collagen fibers would pull on that cut, keeping it open longer, and the scar would be quite big. If I were to get a cut parallel to those lines of cleavage,
the collagen fibers wouldn't pull so much, and it would be a much smaller scar. So thankfully, because of what we know about collagen fibers, we know these guys aren't as old as they look.
Now let's take a more detailed look at skin. You already should be familiar with the epidermis, dermis, and the location of the hypodermis, even though the hypodermis is not part of the skin. In this diagram, you can see that there are nerves in the skin. In actual skin, there would be more nerves, but so you can better see what's going on, the illustration shows only a few. These neurons making up the nerves receive signals and send those signals to the brain. Some of them touch the hair follicles. You might have experienced when you have a fly land on your skin. You cannot feel it because of its tiny mass, but you feel it when it brushes past one of the hairs on your arm. Hair is made up of keratinized tissue, so it is made of dead cells. That's why when you cut your hair, you don't feel any pain. But when your hair is pushed one way or another, the neurons in the dermis sense that movement and send a signal to the brain. They are hair follicle receptors sending a message from your skin, and that's when you rapidly wipe off your arm to scare the fly away. So some neurons in the skin touch your hair follicles. Others are inside the skin, so you can feel other senses such as touch, heat, cold, pressure, pain, itchiness, and even tickling. These are sensory neurons, taking messages from the sensory receptors and sending them to the brain. Your skin is extremely sensitive due to all these nerves. That is why a small paper cut on your finger can be so painful. It is affecting many nerves in your skin. The sensitivity is so great that you can tell the difference between 2 sheets of paper and 1 sheet when you hold them in between your thumb and forefinger. Now let's take a look at a hair follicle and how it relates to skin damage. Perhaps one of the most important functions of a hair follicle has to do with burns. The least damaging type of burn on the skin is a first-degree burn. This happens when you kill several epidermal cells. A sunburn is a common example of a first-degree burn. But the cells of the epidermis are constantly undergoing mitosis, so a first-degree burn can rapidly heal. Second-degree burns result when all of the epidermis is destroyed and some of the cells in the dermis are killed too. Now, this is a much more difficult injury to heal because there are no more epidermal cells at that part of the skin to reproduce themselves. Yet, hair follicles are made of epithelial tissue. Look at the diagram. Can you see the cells around the hair follicle? They are really just an extension of the epidermis into the dermis. So thanks to the hair follicles and their epidermal cells down in the dermal layer of the skin, new skin cells can grow via the mitosis of the cells around the hair follicle. Sweat glands and ducts are also surrounded by epithelial cells, so they also can regenerate more epidermis. What a phenomenal design to provide a protected storehouse for your outer skin layer. We call first and second degree burns partial thickness burns. These mean that there is opportunity for both layers of the skin to heal themselves. Now, third degree burns are much more serious. A third degree burn occurs when both the dermis and epidermis are completely destroyed in an area. It is also called a full thickness burn because the full thickness of the skin has been destroyed. When someone receives a third degree burn, the only way to heal the area is with a skin graft. Doctors will take part of the dermis and epidermis from another part of the body and transplant them to the injured area. Another feature of hair follicles is that they have arrector pili muscles attached to them. These muscles can change the position of the hair. This is how hair can stand on end. When an arrector pili muscle contracts, a small bump forms around the hair. This is what we call goosebumps, small bumps around our hairs when we are cold or scared. This is actually a great mechanism to help our body hold in heat. You see, when our hairs stand in a more erect position, they trap warmer air against our skin's surface, so we can keep warm. Now take a look at the hypodermis layer. It's sometimes called the subcutaneous layer, which means a layer under the skin. It is made of loose connective tissue and adipose or fat tissue. The loose connective tissue is to connect the skin tissue to the muscle or bone below it. The adipose tissue helps to insulate the body from losing heat. It also provides protective padding. Now, depending on the area of your body, the amount of adipose tissue varies. For example, you have no adipose tissue in your eyelids, but there can be a lot more adipose tissue in your torso. Hypodermic needles are for making injections of medication under the skin, hence the name hypodermic. That's because when material enters the hypodermis, it can reach the plentiful blood vessels there and be readily absorbed into the bloodstream. Notice in the illustration several loops of blood vessels near the top of the dermis. Those are the dermal papillae I was talking about. The loops increase the surface area of the epidermis so more of it can be exposed to blood. Sweat glands in the dermis produce sweat that travels up the sweat ducts and out the sweat pores onto your skin's surface. That's a good thing because when your body gets too hot, the sweat is released onto your skin and then will evaporate. As it evaporates, it takes a bit of heat off of your body. Lastly, sebaceous glands produce oil to soften your skin, keeping it moisturized. The oils also help protect your skin from damaging bacteria.